Welcome back, everybody, for another deep dive.
Yeah, great to be back.
Today we're heading back to 19th century Germany,
Okay.
a time of a lot of pretty massive changes.
Absolutely. A lot of innovation.
Innovation, yes. And we're going to meet Carl Ludwig Althans.
Right?
He's an engineer, really interesting guy, and we're going to be looking at his water column engine,
Okay.
which he designed for the Guldenhardt Mine.
Wow.
And what's really cool is we have this firsthand account from Julius von Speer,
Oh, right.
who was a young mining enthusiast at the time.
Amazing.
And he documented, like, everything.
So we're lucky to have that.
Yeah. It's like having a time machine.
Yeah, it really is a treasure trove of information. And to understand, to really appreciate Althans' ingenuity,
Yeah.
it's important to understand the context,
Yeah.
Germany in the 19th century, kind of on the cusp of industrialization.
Huh.
Engineering was like, just bursting with new ideas.
Right.
And industries, like mining, were being completely revolutionized.
Okay, so let's unpack this.
All right.
So let's start with Althans.
Yeah.
Who was this guy?
Well, Carl Ludwig Althans was born in December 1788
Okay.
in Buckeburg, Germany. And he actually spent, his early years at Buckeburg Palace.
Wow.
Can you imagine that?
That's pretty amazing.
Yeah, pretty amazing. But, even with that kind of privileged background, he was drawn to engineering, to problem solving.
So it's like he could have had a life of luxury, but he chose to kind of get his hands dirty and make a real difference.
Yeah, I think that's a great way to put it.
Yeah. So how did he get into engineering then?
Well, from 1807 to 1810, he apprenticed with a really well-renowned figure named Breithaupt.
Okay.
And, that kind of mentorship suggests that he had, top-notch training.
Right.
And it really kind of set the stage for his career.
And his career took off pretty quickly, right?
It did, yeah.
He got a pretty important position, like fairly young.
Mm-hmm. Yeah, in 1814, he became, and this is a mouthful, a Lipscher Bauconductor.
Okay.
Which,
That sounds very impressive.
it does sound very impressive.
What does it mean?
Yeah, essentially, it means he held like a senior role in building and construction.
Okay.
And he was only in his 20s at the time,
Wow.
which speaks volumes about, his talent, his drive.
Okay, so not just a talented engineer, but clearly ambitious as well.
Absolutely.
And it seems like his personal life was also full of both joy and sorrow.
Yeah, that's right. In 1819, he, experienced the heartbreak of losing his first wife, Johanna.
Ah.
However, that same year, he found love again and remarried to Charlotte Schenk in Dillenburg.
Okay, so life was full of twists and turns even back then.
Yeah, absolutely.
But through it all, Althans' creativity flourished. We're talking about a real Renaissance man here.
Yeah,
He wasn't just an engineer. He was also a skilled architect and an inventor.
absolutely. And we actually have these wonderful drawings that kind of show his range.
Okay.
One depicts a classical temple design, very elegant, intricate.
Uh-huh.
Another one shows like a complex mechanical device,
Huh.
possibly for copying drawings.
Oh.
It's clear that his mind didn't, stay confined to just one area.
It's like he was constantly exploring, constantly pushing the boundaries of what was possible.
Yeah, I think that's a great way to put it.
Yeah. And this innovative spirit was really evident in his work on a major industrial project,
Oh, yeah.
the Lohi Iron Works.
Yes, exactly. Between 1822 and 1824,
Okay.
he played a key role in rebuilding the Lohi Iron Works. Think about, the scale of a project like that in those days.
Yeah, massive.
Massive. And, the iron industry was like the driving force, behind the Industrial Revolution.
Yeah, of course.
And Althans was right at the heart of it.
Wow. It's amazing to think about the impact he had, on shaping the industry.
Yeah.
But his interest didn't stop there.
No, they didn't.
He also delves into the world of geology, which, is so crucial for understanding the very earth that they were mining.
Right. That's a good point.
Yeah.
In 1838, he published a book.
Okay.
It's called Grundzüge zur gänzlichen Umgestaltung der bisherigen Geologie.
Okay.
It's a long title.
Yeah, it is a bit of a mouthful.
But, what this shows us is that he wasn't just, a practical engineer.
Right.
He was also a deep thinker, trying to, unravel the mysteries of the Earth's formation.
Yeah.
It's remarkable how he combined, that theoretical knowledge with practical application.
Yeah. And it seems his passion for knowledge and innovation inspired the next generation.
Yes.
Two of his children, Alwine and Ernst Friedrich,
Uh-huh.
followed in his footsteps,
Yeah.
with Ernst becoming a pretty high-ranking mining official himself.
Yeah.
a real family legacy.
It is a real family legacy. And this brings us to, the heart of our deep dive,
Okay.
the Guldenhardt Mine, and Althans' ingenious solution to a very real problem.
Yeah, the mine was facing a challenge that, plagued so many mines during that era.
Yeah.
Water.
Water.
Let's paint a picture for our listeners.
Okay.
Imagine you're a miner, hundreds of feet underground.
Okay.
It's dark, it's damp,
Yeah.
and water's constantly seeping into the mine shafts.
Mhm.
What a nightmare.
Constant battle against the elements.
Yeah, exactly.
And at the Guldenhardt Mine near Herdorf,
Okay.
this water problem was particularly severe.
Right.
They desperately needed a way to keep the mine dry and operational.
Yeah.
So that's where Althans' brilliance kind of shines through.
Yeah.
He devised a remarkable solution,
Okay.
a water column engine.
A water column engine. This is where I need you to break it down for me.
Right.
How does a machine powered by water actually work?
Okay, so it's a fascinating concept. Imagine a tall vertical pipe
Okay.
filled with water,
Okay.
and the sheer weight of that water column creates immense pressure. Right. And so Althans' engine harnessed this pressure
Okay.
to power a pump that removed water from the mine.
So it's like using the problem itself, the water,
Yes.
to solve the problem.
Exactly. Using the water to get rid of the water.
That's amazing.
Yeah, it's really clever.
And what's even more amazing is that we have, Spare's detailed account of this engine.
Yes.
And we're not just talking about some vague description.
Yes.
He documented everything so meticulously.
Exactly. We have drawings showing the engine's placement within the mine.
Oh, okay.
It's interesting. It wasn't directly above the mine shaft.
Okay.
It was actually kind of near the entrance of the deep tunnel.
Oh, interesting. Okay.
Yeah, and this is because the engine was powered by water that was channeled from a nearby stream
Okay.
through a system of canals and pipes.
Oh, so they were clever. They were using gravity
Exactly.
and the natural flow of water
They were really smart about that.
to their advantage. So they positioned the engine strategically to maximize efficiency.
Yeah, they were very clever about that.
And you said Spare documented every detail.
Yeah.
What kind of details are we talking about?
Well, I mean, he described everything, the cast iron pipes, the valves, even the massive oak beam
Wow.
that they called the brushwing,
Okay.
which acted as kind of the backbone of the engine,
Yeah.
supporting all that pressure.
Right.
He even detailed this intricate network of levers, rods, and gears
Okay.
that, transferred the engine's power to the pump deep in the mine shaft.
So it sounds incredibly complex.
Oh, it is.
It's like this giant mechanical ballet.
Yeah,
All these moving parts working together in harmony.
absolutely. And Spur didn't just describe the parts.
Yeah.
He documented their dimensions, the materials used, even the techniques for assembling and sealing the pipes.
Right.
He talked about kitsilin, which are, these hemp ropes
Yep.
soaked in this mixture of wax, pitch, and turpentine
Wow.
to create a watertight seal.
Oh, okay.
Yeah, they were meticulous about every detail because, any leak could have been disastrous.
Right, of course. When you're dealing with that much pressure,
Yeah,
there's no room for error.
exactly.
And Spare wasn't just observing, he was analyzing, calculating, really trying to understand how this machine worked, at its core.
Absolutely, yeah. He provided calculations, of the engine's efficiency and power output. And he even described the engine running with the greatest lightness while pumping 6 cubic feet of water per minute. Imagine the scene. The rhythmic chugging of the engine, the relief of the miners as the water level drops,
Yeah.
knowing they could work safely and efficiently.
It must have been an incredible sight.
I think so.
Yeah. And a testament to Althans' vision and Spur's meticulous documentation. This is, just the beginning of our deep dive.
Yeah.
Next, we'll delve into the, the nitty-gritty of how this water column engine actually worked, step by step.
Step by step.
So are you ready to get technical?
Let's do it. I'm ready to unpack the mechanics of this marvel of engineering. All right, so let's dive into the mechanics of this water column engine. Okay, so it all starts with harnessing the power of gravity.
Okay, so how did they actually get the water to the engine? Did they have to, carry it up buckets?
No, thankfully, no buckets were involved.
Okay.
They were much smarter than that.
Okay, good.
Remember those canals we talked about that channeled the water from a nearby stream?
Yeah.
Well, that water flowed into a reservoir that was situated uphill from the engine house.
Ah, so they were using the natural elevation to create like a water power station.
Exactly.
That's clever.
Yeah. And from this reservoir, the water flowed down through two large vertical pipes.
Okay.
Think of them like giant water towers.
Right. Okay.
Speer referred to them as the Einfallrohren.
Okay, so those must be the pipes delivering the water to the engine itself.
Right.
And I remember you mentioned this mysterious Steuerstifel earlier.
Yes.
What's that all about?
Okay, so the Steuerstiefel, this was like the brain of the operation.
Okay.
Picture a large vertical cylinder
Right.
containing two pistons connected to a single rod.
Okay.
And these pistons, they acted like valves,
Okay.
controlling the flow of water into the Kraftstiefel.
Wait, so there's another cylinder?
Yes.
Is that where the actual like pumping action happens?
You got it. You're on the right track.
Okay.
So the Kraftstiefel, this housed the main power piston.
Okay.
And here's where the weight of the water in those vertical pipes, this Einfallrohren, really comes into play.
Right. Okay.
The pressure from that water column, it pushes down on this piston,
Yeah.
forcing it upwards with immense force.
So it's like a giant water-powered elevator.
Yeah, that's a great way to think about it.
That's pretty impressive.
Yeah, it is.
So as this power piston moved upwards,
Yeah.
what happened?
Well, it turned a large wheel that was called the Leittrad.
Okay, the elytrad.
Okay. And this wheel was connected to a system of rods and beams that extended horizontally all the way into the mine shaft,
Okay.
ultimately reaching the pump.
Okay, so this Lytrad was like the central gear,
Right.
converting the vertical motion of the piston into the horizontal movement
Right.
needed to drive the pump deep in the mine.
That's a great way to put it.
Yeah.
It's like this
Uh-huh.
giant lever system, transferring the engine's power from the surface deep underground.
Yeah.
And with each upward thrust of that power piston, the pump would lift a certain amount of water out of the mine.
Okay, I can almost hear the chugging of the engine and the whoosh of water being pumped out.
Yeah.
But wait a minute, how did the piston get back down after being pushed up by all that water pressure?
Okay, that's where the ingenuity of Althans' design really shines.
Okay.
He incorporated a counterweight system.
Okay, so like a weight.
Exactly. So essentially, a heavy weight was attached to the opposite side of the Leittrad,
Okay.
and as the power piston reached the top of its stroke, this counterweight would pull it back down, ready for the next cycle.
So it was like a perfectly choreographed dance between the force of the water and the pull of the counterweight.
I like that analogy, yeah.
Yeah.
Yeah, it was this beautiful balance.
And what about that regulator you mentioned earlier?
Ah, yes, the regulator, that was crucial for controlling the engine speed.
Okay.
It consisted of two arms that could adjust the flow of water into the Kraftstiefel.
Okay.
And by controlling the flow, they could fine-tune the engine's power output.
Right.
Speer even described a planned improvement.
Oh, really?
Yeah, a float system that would be connected to the regulator
Okay.
that would automatically adjust the engine speed based on the water level in the mine.
Wow. It's like they were on the verge of creating like a self-driving pump.
Right.
I'm blown away by their ingenuity.
Pretty impressive.
But let's shift gears a bit and talk about Speer's calculations.
Oh.
He didn't just describe the engine.
Yeah.
He measured and analyzed its performance, right?
Mhm. He did. His notes are filled with precise measurements and calculations.
Wow.
He documented everything.
Okay.
The dimensions of the pistons, the height of the water column, the amount of water pumped per minute.
Yeah.
He was a true scientist at heart.
Okay, so what kind of performance did this engine achieve? Give us the numbers.
Okay, so based on Speer's meticulous calculations, he estimated that the engine could lift 6 cubic feet of water per minute
Okay.
from a depth of approximately 140 feet.
Wow. Okay. And how much is that like in horsepower?
Yeah, so to put that in perspective, he calculated that this was equivalent to the power of approximately 4 horses.
4 horses. So this one engine could replace an entire team of draft animals.
Exact.
It makes you think about the impact this must have had on the mining industry.
Absolutely.
Like no more feeding, caring for, resting those horses.
All right, all those costs.
This engine could operate continuously as long as there was a steady supply of water.
As long as there was water, yeah.
Yeah, it's like a snapshot of the Industrial Revolution in action. Machines replacing muscle power.
Absolutely.
But what about efficiency? Did
Right.
Speer delve into like how much energy the engine used compared to how much work it produced?
Yes, he did. And based on his calculations, he determined that the engine had an efficiency of around 45%.
Okay, so 45%, that might not sound like much today, but considering the technology available at the time.
Yeah.
That's pretty impressive, right?
Oh, it is. Yeah, they were working with relatively basic materials and, limited understanding of fluid dynamics.
Right.
So achieving 45% efficiency with those constraints.
Yeah.
It's really a testament to Althans' innovative design and Sperr's meticulous analysis.
So,
And Sperr even believed that the engine's true efficiency was likely closer to 70%,
wow, okay.
but he couldn't accurately measure it,
Right.
under the mine's operating conditions.
That's fascinating. It makes you wonder what other insights they could gain, though. They had, more sophisticated measurement tools.
Right.
But the fact that they documented and analyzed everything so meticulously is remarkable in itself.
Absolutely. Yeah, Sperr's documentation wasn't just, a dry technical manual.
Wow.
It was really like a window into the mind of a pioneering engineer,
Yeah.
capturing the challenges, the innovations, and the thought processes behind solving problems, in that early industrial age.
It's like a time capsule of knowledge and ingenuity.
It's amazing to think
What's that?
that for years, this incredible piece of engineering was basically a footnote in history,
Huh?
known only through some documents and drawings.
Wow.
But now it's like a forgotten symphony,
Right.
just waiting for someone to rediscover the score and bring it back to life.
And that's where these digital reconstructions come in.
Yeah.
They're not just bringing the Guldenhardt engine back to life visually,
Right.
but they're letting us hear it,
Sure it.
understand its rhythms and its movements
Yeah.
in a way that static images never could.
It's a whole new level of understanding.
It is.
And these reconstructions, they're not just pretty visualizations.
Right.
They're based on meticulous research,
This
Sperr's description,
Althans' original plans.
even modern engineering analysis,
Wow.
to create a virtual model that accurately reflects how the engine actually worked.
So it's like having a time machine.
It really is.
We can step into that mine in the 1840s
Yeah.
and witness this marvel of engineering in action.
It's incredible.
But beyond the visual spectacle,
Uh-huh.
what can these digital reconstructions teach us
Oh, so much.
about the Guldenhardt engine
Yeah.
that we couldn't learn from the historical documents alone?
Well, for one thing,
Yeah.
they let us study the engine's operation in detail.
Really?
We can see how each component interacted with the others.
Wow.
We can
Wow.
analyze the flow of water,
The movement of the pistons,
the stresses on the beams,
all in a
in
dynamic.
an interactive way.
It's amazing.
It helps us understand not just what the engine did,
Right.
but how it did it.
That's
It
fascinating.
really reveals the brilliance of Althans' design.
So it's not just about recreating the past.
Yeah.
It's about using modern tools to gain a deeper understanding of it.
Exactly.
And this understanding has implications beyond just historical curiosity.
Absolutely.
Yeah.
Exactly.
So what does this all mean? What's the takeaway from this deep dive into Althans' remarkable creation and Sperr's insightful documentation?
Well, I think the biggest takeaway is the power of human ingenuity. Faced with a real-world challenge, flooding in the mines, Althans came up with this brilliant solution that harnessed the power of nature itself.
Yeah.
And thanks to Sperr's meticulous documentation, we can appreciate not just what they built,
Yeah.
but how they thought, how they approached problem
Wow.
solving, and the impact their innovations had on the world around them.
It's a story of collaboration, innovation, and the transformative power of technology. It's a reminder that even with seemingly limited resources, remarkable things can be accomplished when brilliant minds come together.
Absolutely.
So this water column engine, it wasn't just like a marvel of engineering for its time.
Right.
It really highlights this spirit of innovation that was sweeping through these industries like mining in the 19th century.
Absolutely. It's a fantastic example of how, engineers were finding creative ways to harness the power of nature.
Yeah.
They weren't just relying on brute force. They were, observing, experimenting, finding elegant solutions.
And what's so valuable about Sperr's documentation
Yeah.
is that it allows us to peek into that process,
Yeah.
to see that the evolution of their thinking.
Right.
It's not just a technical manual.
No.
It's like a historical record of human ingenuity.
Precisely. And we see that in his, detailed descriptions of the engine's construction, but also in his calculations and analysis.
Yeah.
He was trying to understand not just but the why, the scientific principles behind the engine's operation.
So he wasn't just building a machine.
Right.
He was unraveling, the physics of water pressure,
Yeah.
energy transfer, efficiency.
Absolutely.
It's almost like he was laying the groundwork for future engineers to build upon.
Yeah. And that's what makes his work so relevant even today.
Right.
It reminds us that engineering is this process of continuous learning and improvement.
Yeah.
We stand on the shoulders of those who came before us, just as Spar was building on the knowledge and techniques of his time.
Okay, so what does this all mean for our listener today?
Okay.
Why should we care about a water column engine
Yeah.
from the 1840s?
Well, I think there are several key takeaways.
Sure.
First, it highlights the importance of careful observation and documentation.
Right.
Spar's meticulous notes have allowed us to understand this invention in a way that wouldn't have been possible otherwise.
Yeah.
Imagine if he hadn't taken the time to record all those details.
Right.
We might have lost this valuable piece of engineering history.
It's a reminder that even seemingly small details
Yeah.
can be crucial for understanding the bigger picture.
Absolutely.
And second, this story emphasizes the power of collaboration.
Yes.
Althans had the vision,
Yeah.
but it took a team of skilled craftsmen and engineers to bring that vision to life.
Yeah, it wasn't a solo effort.
Right.
It was really a testament to the collective ingenuity of a group of people working towards a common goal.
It's inspiring to think about, how much they achieved with the resources available to them.
Right.
It really underscores the power of human ingenuity and collaboration.
Yeah.
And finally, this story prompts us to think about the impact of technology.
Right.
This water column engine wasn't just a cool contraption.
Yeah.
It solved a real world problem.
Yeah.
It made mining safer, more efficient.
Absolutely. It's a reminder that technology at its best can serve humanity. It can solve problems, improve lives, and push the boundaries of what's possible.
And it all starts with, curiosity, observation, and the willingness to experiment and learn from those who came before us.
Yeah, I think that's a great point.
So the next time you encounter a challenge,
Yeah.
remember Carl Ludwig Althans
Yeah.
and Julius von Spar.
Remember their ingenuity.
Remember their meticulousness and their collaborative spirit.
And think about how you can apply those same principles to solve problems,
Yeah,
innovate, and leave your own mark on the world.
that's a fantastic note to end on.
Yeah.
Thanks for taking us on this fascinating journey back in time.
My pleasure.
Until next time, keep exploring, keep questioning, and keep diving deep.